Okay, in this video we'll talk about how to run a simulation for your rocket. And you'll see I have a pretty complete basic build, and I've added some things since the last video. We've got lower and upper centering rings, we've got a parachute, we've got a shock cord, all sorts of good stuff. And this one's pretty much ready to go. I've actually played with my stability, so I have a good stability number, 2.81. It's a pretty good number when it comes to that. And I can keep dialing it if I wish, but it's far enough along just to show you what a simulation will look like. Also, to get that stability, I had to note I actually had to add some mass up here to get my center of gravity, center of mass to move forward on that. So just things like that you have to do. So to run a simulation, you're going to go to Flight Simulations up here. We're going to do a new simulation. That's going to open a window, and it gives you some choices. This is about launch conditions. You can play with the wind, atmospheric condition, what's the temperature, things like that. What about the launch site? Where is it? And with the launch rod, the one that I pay attention to on launch rod is launch length. 60 inches is appropriate, and that's about the size we'll be using to launch the rocket. That does make a difference because it impacts your launch velocity, which we want a good launch velocity. You're welcome to play with these. I actually don't play with them very much. I just pay attention to my launch rod length. We're going to come down here and click Simulate and Plot. We're going to get another window that lets us talk about different aspects of what we'll be graphing. We're going to be looking at altitude, vertical velocity, and vertical acceleration. You can affect the units as you work with that. This is a vertical motion versus time graph. X-axis is going to be time, so the horizontal axis will be time. And we'll see these on the vertical axis, as you can see right there. I actually don't play with this very much either. I might change the units just because I'm curious. There's different events you can put in the graph right there. You're welcome to play this and see what you learn. Can't hurt anything. But do save often. In making this video, it's crashed on me twice so far. So let's look at a plot. You'll see a graph like this. And this is a flight of your rocket, and you'll see the red is altitude, the blue is vertical velocity, and the green is vertical acceleration. So you have three graphs in one happening here. Horizontal axis is time. And you'll get information like, it says recovery device deployment. That's the parachute. Apogee, highest point of the rocket. Notice that the parachute came out after the rocket reached the highest point. That's a good thing. Motor burnout, motor ignition. So there's information about this graph. And this is a graph you want to be able to explain. I'll ask you questions about your rocket's performance, and I want you to be able to point to this graph and tell me from the graph what your rocket is doing in the simulation. It also gives you information so you can see how to modify your rocket to meet some of the needs that you have for your rocket flight. We're going to close this. We're going to close this, and we're going to see a data table now. Across the data table for this simulation, a green check is really good. It says this rocket's is flying in a stable format. There's our rocket motor. It's coming off of the rod at 14.3 meters per second. That's a good number. We want at least 12 meters per second. Highest point, apogee, is 1,016 feet. We have velocity of deployment. That's when the parachute came out. How long should we delay before we pop the parachute, and that is, separate the rocket? About 5.3 seconds after the motor burns out. So our 6-second delay is quite good. Max velocity, max acceleration. How long is it going to take to get to the top? How long is it going to be in the air? A little over a minute it's going to be in the air. And ground speed. When it hits the ground with the parachute deployed, it's going to be going 5.72 meters per second. That's a good number. You want it somewhere between 5 and 6, preferably between 5.5 and 6 meters per second. Too fast, you break your rocket when it hits the ground. Too slow, the wind takes it away and you never see your rocket again. So it's somewhere in between. That's what a simulation looks like. You can change things in here and run a new simulation. You might change the work with your fins a little bit to move your stability number around. There's different things you can do to affect the performance of your rocket. So that's how you run a simulation. Please play with it, goof around with it, things you can do, and just explore and try to make that rocket the rocket you want. If you want altitude, trying to get for a lot of altitude, keep playing with it until you get a design that gives you high altitude. That doesn't matter to you. Don't worry about it. Just build a stable rocket. Okay, so that's it for showing some type of simulation with your rockets.